Yes. See, students, in the previous class, we discussed about adiabatic process. No? Yes. We discussed about adiabatic process. What is adiabatic process, Nana? What is adiabatic process? It is a process in which change in heat energy is zero. We have discussed this one. Clear? Yes. Now I am going to prove one equation in adiabatic process that already in yesterday's class almost we have proved it. Let us prove it one more time. Okay? Yes. See, as we know, PV is equal to nRT, ideal gas equation. You know this equation. Clear? Yes. Now, for this equation, I am going to take derivative with respect to temperature. Means d by dt of PV I am doing is equal to d by dt of nRT nana. Okay, yes. What I am doing, I have taken one ideal gas equation. For that ideal gas equation, I am going to do derivation. Derivative, I am going to take a derivative with respect to temperature. As we know, this is pressure, this is volume. These are variables. Pressure and volume will change in adiabatic process. So students, sorry students, it is disconnecting. I'll try to So what I have taken? I have taken PV is equal to nRT, and for this I am taking derivative with respect to temperature. We'll get this equation. As P and V both are variables, so first I am taking pressure constant. So take derivative of volume with respect to temperature. And now you consider volume as constant. Take derivative of pressure with respect to temperature. UV form I am using. Derivation of UV, UdV plus VdU, that format I am using, is equal to NR constant. You will get dt by dt. This dt cancel. Okay? Yeah. So we can write this as PdV plus VdP upon dt is equal to NR. We can write. Clear? Yes. So in the last, we can write PdV plus VdP is equal to NR dt. We can write. Let us take this equation number 1. Okay? Yes. One more thing. See, in adiabatic process, as dq is equal to 0 in adiabatic process. So we know dq is equal to du plus dw. As dq is 0, that implies dw will become minus du. We know dw is nothing but PdV. Work done by the gas is PdV. And du is equal to F by 2 nR dt. You know this, yesterday we have discussed. From this one, what is nR dt, Nana? nR dt is nothing but minus 2 by F PdV. Okay, this is equation number 2. Let us take. Substitute equation 2 in equation 1. In this equation, let us substitute this. What we will get? Let us check. We will get PdV plus VdP is equal to, what is there, Nana? NR dt. What is NR dt? Minus 2 by F PdV. That I will substitute there. Minus 2 by F PdV. Clear? Yes. Let us send this one this side. Audio not clear. Okay. Maybe network problem, Nana. Check once. Maybe network problem it is. Yours or mine. Okay. Yes. So we will get PdV plus VdP plus 2 by F PdV is equal to 0. Correct? Yes. So PdV, let us take common. Here you will get 1 plus here you will get 2 by F plus remaining, this is remaining. VdP is equal to 0. Now this this 1 plus 2 by F, I am taking 1 plus 2 by F. This total value, I will take it as gamma nana. So it can be written as gamma times of PdV plus VdP is equal to 0. Clear? We can write gamma times of PdV is equal to minus VdP. Now gamma times of dV upon V is equal to minus dP by P. We can write. Clear? So just V send this side, P send this side. Clear? Yes. Now let us integrate this equation. We will get integration of gamma times of dV by V is equal to integration of minus dP by P. Okay. This integration from where to where we need to do. This integration we have to take it from initial volume to final volume, and here initial pressure to final pressure. Clear? Yes. Now, as gamma is constant, it will come out of the integration. You will be having integration of 1 by V dV. You are having integration of 1 by V dV. V initial to V final is equal to minus, let us take common, we will get integration of 1 by P dP. P initial to P final. Okay? Yes. Now, I'll take one more slide. You will write gamma. Now see here, integration of 1 by V dV is what? Log V. You know this formula. So I'm writing log V. But this is having limits, no? Yes. From where to where? V initial to V final is equal to minus integration of 1 by P dP is again log P. Log P. And it is also having limits. P initial to P final. Yes. Now, gamma times of apply limits Gauss. Sorry, one more time, one more listen here, one point here. Before applying limits, before you are applying limits, send this gamma inside. You will get log of V power gamma. Clear? Yes, how sir? N log x can be written as log x power n, like that. This n will go to this power. That's it. Okay? Clear? Yes. Now, so this will come log V power gamma, and it is having limits. V initial to V final is equal to minus log P initial to P final. Okay, yes. So let us apply the limits. Log V final power gamma minus log V initial power gamma, we can write, is equal to this one minus of log P final minus log P initial we can write. Clear? Yes. This is in the form of log x minus log y. It can be written as log of x by y. Means log V final power gamma divided by V initial power gamma. Okay, is equal to this. I'll write a minus. I'm sending inside. It will become log P initial minus log P final. No, yes, send it inside this one. Okay, yes. So this equation totally it will become like this: log of V final power gamma divided by V initial power gamma is equal to log of P initial by P final. Now apply anti-log both sides. Log will cancel. You will get V final power gamma upon V initial power gamma is equal to P initial by P final. Let us cross multiply it. We will get P final V final power gamma is equal to P initial V initial power gamma. That means P V power gamma is constant. This is the point I am trying to get from yesterday onwards. In adiabatic process, what is the equation to say is P V power gamma is constant. That means, see students, if you take isothermal process, isothermal, what you will get? Temperature is constant. That implies PV is equal to constant. This is the equation that we will apply for isothermal process. Whereas for isobaric process, what will be constant, Anna? Pressure will be constant. That implies V by T will be constant. From ideal gas equation, I am writing these equations. Okay. Next, isochoric process you take. Isochoric process. Isochoric process means volume will be constant. If volume is constant, means P upon T should be constant. Now you take adiabatic process. Adiabatic process. What will be constant, Anna? dQ will be 0. That implies PV power gamma is constant. Yes, these are the important points that we need to learn. This just now we have derived. Yes. What Shabas? Your raising hand. It is showing Shabas raised hand. Why? What is the reason? Two participants raised hands. See students, just now I have noticed one thing. Whenever you will send messages to me, not only for this class, I think so this will happen for all the subjects. Whenever you will send messages or something, raise hands, no? I think so this Zoom app is somewhat it is tracking, so that your audio and video somewhat it is tracking. Keep in mind that one. If it is required and necessary, then only you send. Sir, network problem, can't listen. Shabas is saying that, sir, network problem, we can't listen. Is it happening for all of you? I forgot to record this video. Friends, 10 questions. Yes, it is recording. Strucking, sir. No, sir, it is recording. Okay, sorry. Shivakumar is saying that audio is clear. No. Strucking. Maybe It may be your network problem or it may be my network problem, Nana. We are getting this issue. Can't hear only, sir. Why you can't hear? Okay, Nana. Okay, sure. Okay, Nana. Let us resolve it. Today I am using Airtel network. Yesterday I used. Okay, students. Okay, let us go to that point. Yeah, see, in adiabatic process, P V power gamma is always constant entities. Okay, P V power gamma is constant always. This you need to remember. Okay, yeah. And another point also we may get here, said that is P V power gamma is equal to constant. This gamma value is what, sir? This gamma is nothing but Cp by Cv. In previous class, we have derived this one. Gamma means Cp by Cv. Okay. And it can be written as 1 plus 2 by F. Means if we know Cp and Cv are F only, we can find gamma. Here, F is degree of freedom. F value depends on atomicity of gas. Means either monoatomic gas or diatomic gas or triatomic gas or polyatomic gas, like that. Okay. In questions, they will mention this gamma. Which gas it is, monoatomic or diatomic or triatomic, like that. About this F, we will discuss in next chapter. So simply you can calculate the value. Let us suppose for monoatomic gas, F value is 3 nana. 3 degree of freedom it will have. Means what is that? We will discuss in detail about in next chapter. Nana. Means one take gas molecule. It is free to move in all directions. Means it can move along x-axis, along y-axis, and along z-axis. So its degree of freedom is 3. Like that we'll take. Then what will be the gamma value? Gamma is equal to what? Na? 1 plus 2 divided by F. That means 1 plus 2 by 3. Nothing but 5 by 3. So 5 by 3 is gamma value for what? For monoatomic gas. Did you understand? Like that we will calculate. Okay. Yeah. Another important point we are discussing, that is P V power gamma is equal to constant, no? Yes. This still we can write in other format also in terms of volume and temperature, pressure and temperature also. Let us see that. As we know, PV is equal to nRT. We know this. Abhay and Shabaz raised hand. Why? Why you are raising hand, Nana? Abhay? Send message. What is that? Okay, just see, don't listen, Anna. Just see, I'll write everything on that board. Huh? Now, see here, what is P, Anna? nRT by V. Substitute this P here. You'll get nRT by V, V power gamma is equal to constant. This N and R are constant. These are constant. So you'll get T V power gamma minus 1 due to these two. Should be constant. This is also equation you need to remember. Okay. Yes. Now, one more we are having PV is equal to nRT. Now, what is V none? V means nRT by P. Substitute this here. We'll get P into nRT by P whole power gamma is equal to constant. It can be written as P T power gamma divided by P power gamma is equal to constant. Since N and R are constant, these are constants, that's why. Okay, means this can be written as P power 1 minus gamma T power gamma is equal to constant. This is also another point you need to remember. You need to remember this also. So total 3. P V power gamma constant, T V power gamma minus 1 constant, or P power 1 minus gamma, T power gamma is constant. Okay? Yes. This can be written as T V power gamma is also constant, or P power 1 minus gamma, T power gamma is also constant. These are the 3 equations which describes adiabatic process. Here gamma is ratio of specific heat capacity Cp by Cv, gamma value. I hope you are understanding somewhat. I think you are understanding somewhat. Now any issues are there now, students? Any issue? Can you hear clearly? Yes, I'll ask to Muskan. Muskan, can you hear me clearly? Muskan? Vaibhav? Nana Vaibhav? Are? Yes. No, sir. Yes, sir. See, by Shabas, they are saying there is no better than before, Muskan. No, here not hearing problem, Saujanya. Better than before means when? Before means when it is, Muskan? Now only, yeah? Okay, let us go to next top point, Nana. Okay, next point you see. Okay, Anna. Okay. Let it be. We will discuss next point. Okay. Now see, Indicator diagram for adiabatic process. Indicator diagram for adiabatic process. Here volume should be there, here pressure should be there. Okay, this is y-axis, this is x-axis, and the graph will be like this. Graph will be like this. Okay, isothermal process graph what, sir? Isothermal. It is also like this. Then what is the difference between these two? Between these two, what is the difference? That we need to know. Okay. For that, let us take one process. For example, you take one monoatomic gas you take. Monoatomic gas you take. For this gas, we know gamma is 5/3. Just now I told you. Okay? Yes. Now, let us take, initially they are having initial pressure P0, initial volume V0, initial temperature T0. Okay? Now, if we increase the final volume to 2V0, then what is pressure? Let us check. Okay, in isothermal process, we know PV is equal to constant. That means P1 V1 is equal to P2 V2. P1 is P0, V1 is V0. P2 is we need to find, V2 is 2V0. What will happen now? V0, V0 cancel. So P final will become P0 by 2. It is in isothermal process. See in adiabatic process. Adiabatic process. PV power gamma is constant. That means P1 V1 power gamma should be equal to P2 V2 power gamma. P1 value is P0, V1 value is V0 power gamma. Gamma means how much? 5/3. Okay, let it be 5/3 is equal to P2 is we need to find, V2 is 2V0 whole power 5/3. It will become P0 V0 power 5/3 is equal to P2 into V0 power 5/3 into 2 power 5/3. Are you getting this? Is V0 power 5/3, V0 power 5/3 cancel. What we will get, Nana? We will get P final is equal to P0 divided by 2 power 5/3. This is the final pressure in adiabatic process. Now, among these two processes, what we have taken? We have taken one monoatomic gas, 1 moles, let us suppose, whose atomicity is 5/3, let us suppose. Okay, now initial pressure, initial volume, initial temperature I have given. Let us suppose we are increasing the volume by 2V0. Then what happened to the pressure? Let us see. In isothermal process, pressure will become P0 by 2, exactly half. Whereas in adiabatic process, pressure will become still less. This is more than half, no? Clear? Yes. That means if you take this is volume, this is pressure. Initially from P0, two processes are moving. Okay. Yes, from here. One process occurred like this. This volume is 2V0. This volume is V naught. Another process occurs like this. This pressure is P naught by 2. This pressure is P naught by 2 power 5 by 3. Means this is isothermal process. Then this will be adiabatic process. Did you understand what I am saying? Isothermal process and adiabatic process. Slight difference. Two curves will be like a parabolic, but isothermal process will be up. Adiabatic process curve will be down. That is the difference. Did you understand, students? I hope you are understanding clearly. Vaibhav, are you there, Vaibhav? I did not get any message from you, Vaibhav. Okay, na? Clear, students? Okay, na? Yeah. Yes. So, students, in next class, we will discuss about second law of thermodynamics. Okay, we will discuss second law of thermodynamics in next class. And this is for today's class. We will continue next class. Okay. Okay. Bye.